Our last lesson in Chapter 4 of the Elementary Statistics course is the applications of our last lesson, counting. Some things to keep in mind as you move forward in this particular lesson. If a question is asking you how many or in how many ways, the answer will be your sample space. Typically, that's a whole number. Remember that if order matters, use permutations. If order doesn't matter, you want to use combinations. If needed, you can always use the counting rule. If a question is asking you what is the probability of, remember that your answer must be between 0 and 1, and typically in fraction form, although remember that decimal form is also acceptable, especially when probabilities are very, very small. Here's an easy example to start off with. In a class of 7 students, there needs to be a group selected of 4 students. There are 4 boys and 3 girls. What is the probability that the group will consist of 2 boys and 2 girls? The first thing I need to do is find the total number of groups. I'll do that by doing 7 choose 4, which is 35. That means 35 groups are in total are possible. The groups that consist of 2 boys and 2 girls would be 4C2 times 3C2, which is 18. That means there are 18 possible groups of 2 boys and 2 girls. Creating the probability now will take the number of 2 boy and 2 girl groups I have over the total number of groups possible. 18 out of 35 is my probability. Let's go to a little bit more difficult example. An electrician is called in to do a test in a current cable. There are 5 color-coded wires. He needs to find a 2-wire pairing that does not function properly. What is the probability that he finds it on the first try? It's a 2-wire pairing, and there are 5 color-coded wires. So I have 5 wires, I need to choose 2, so there are 10 possible different tests to do. We're talking about one try only. Therefore, my probability of getting it on the first try is 1 out of 10. Here's the hardest type of example you might see. Someone is simulating 16 coin tosses over and over and is consistently getting 8 heads and 8 tails. He claims that this is a usual occurrence. Is he correct? What we need here to do is 2c1 to the 16th power. There are 65,536 different possibilities. 2c1, remember, means that we have 2 possibilities and we need to choose 1, and we need to do that 16 times. 16 times we need to choose a result. For consistently having 8 heads and 8 tails, it doesn't matter what you throw on the first 8, but it's going to matter what you throw on the last 8. So 2c1 to the 8th power times 1c1 to the 8th power gives me 256. So there are 256 ways to get 8 heads and 8 tails. Therefore, the probability of getting this is approximately 0.0039. Since it's less than 1%, it is unusual to get exactly 8 heads and 8 tails over and over again. Homework in this section will be textbook pages 189 to 191, numbers 2 to 32 even.